Back in 2016, I lit a ballet at the Ballet am Rhein in Dusseldorf. I thought this project would be an interesting way to look at the recent addition to Vectorworks of schematic views for lighting positions. The rigging tools in Vectorworks are great at quickly generating standard rigging positions, such as ladders, pipes and trusses. But many productions use custom-made objects or site-specific structures, which will only work with the architecture of the venue they've been designed for. Schematic views are a device within Vectorworks that will generate a diagrammatic layout of the items associated with a 2D or 3D rigging position, regardless of its orientation in the three-dimensional model. They are important in that they by and large solve the decades-old quandary about how to interactively represent 3D modelled equipment in a 2D diagrammatical fashion. We also used Renderworks images as part of our design process, which was interesting and thought-provoking for the production team, and I'll talk through my approach to that method of working. The ballet I lit was a piece called Tenebrae by the choreographer Hubert Essekow, with designs by Merle Hensel. When I created the plots for the show back then, I used the Create Plot and Model View function to help me visualize the sidelight elements of the production, as well as letting me represent lighting on the multi-level bridge position that most opera houses have. This approach to drafting used to work well, but was rather a labour-intensive method which required meticulous naming of viewports and layers, which can often be hard work, especially when I wanted to quickly render a beam of light in order to show the choreographer an idea. The set for the production consisted of 3 translucent screens with these fantastic designs applied to back projection material. There was also a complete backlit cyc which was similarly overpainted like this. There was quite a lot of discussion about how we would light these screens, and it became clear that the LED panel or light box route was not really going to be an option, so it was decided that we would simply backlight them from the rig overhead. I spent quite a lot of time thinking about how I would render these screens using Renderworks, and experimented with light-emitting glow textures, which was definitely a quick way to generate some visuals to show the screens emitting light. It was also obvious to me that the glow textures looked better on the rendering, and in all probability, an effect like this was going to be very difficult to achieve without the ability to internally light each surface. The reality was going to be that the screens were to be aluminium frames with overpainted projection material stretched across the front face. To render this effect in Vectorworks, I would need to create 2 Renderworks textures. One which was a backlit texture with a simple backlight shader applied to it, and then immediately in front of it, a transparency layer made from the images provided by the designer. By backlighting the textures using a lighting device set to realistic, I reckon the results were a more faithful representation of what could be achieved with real lighting equipment. I still felt that the rendered results were a little idealistic, but we decided on it anyway. As this is a rep house with a different show most days of the week, the turnaround time for focusing was going to be tight, and the screens would need to be lit with stock moving lights. This 3D model of the stage and proscenium shows in reasonable detail how the stage was configured, and most physical elements can be controlled using classes and design layers. Back in 2016, the process required me to remove all the solid fill from the lighting devices so I could see the shutter shadows rendered in OpenGL. Now using data visualization, I can assign a translucent texture to the body part of the symbol the lighting device uses, and the light will project through the body geometry. This makes the process much less labour-intensive. It is still quite labour-intensive though, and for me it took quite a while to frame the shutters around the screen geometry. I do still think the results are a little too idealised, even with this method, but I reckon that what could be achieved in the theatre would be closer to this version, and it was quite good to prove the lighting shots using beam angles that were going to be achievable in real life. A key element for lighting designers in most European opera houses is the lighting bridges, and they are normally stocked full of equipment that can be easily refocused for each show in the repertoire. With 3D models of lighting rigs, it can be a little tricky to show this, and I have found that putting each pipe on a separate design layer is the best way to manage the drawing. These 3 levels and the schematic views that are created work perfectly within this scenario. When I am looking through 3D rendered lighting rigs, it is often easy to miss problems because lighting equipment is invariably painted black. Again, data visualization can be helpful, and a quick change of texture will change the colour to something a bit more noticeable. Here is a symbol of the geometry for the boom towers I'm using for this production. These are stock items that the Ballet company use, and the measurements were provided as part of the inventory. The towers consist of some geometry that I created using some fairly rudimentary modelling techniques, and are meant to represent box steel. There are also some nested symbols with the geometry. These are primarily for using as objects to attach lights to, and they contain a toNURBS curve for using as a smart edge when aligning lighting devices, as well as a 3D locus which I have set to be a master snap point. This makes it much easier to attach lighting devices, as master snaps are designed to take priority over other snaps but won't be visible until the cursor finds them. Ultimately, it's all about decluttering. I'm going to use this symbol as a hanging position, which will eventually be able to provide the geometry for schematic views. There's a little bit of a process that needs to be carried out. However, the goal is to make this a reliable hanging position to use for all 10 of the lighting towers that are needed for the production. Fundamentally, what lighting designers and electricians need to be able to do is create a schematic drawing of the full length of this position, along with a diagram or representation of the lighting devices. This diagram already exists in the top component of the lighting instrument symbol, so we need to create a hanging position that will do the same. The top view that I want to see is actually the front or back of this tower, and I want to represent the lights as they appear in 3D from the top to the bottom. Because the components of all Vectorworks lighting devices are pointing north or upstage as a home position inside the symbol, then it seems reasonable for the upstage of this tower to be the top view. So what I need to do is rotate the symbol. So using the rotate tool, I grab the insertion point as the point of rotation and rotate the tower until the upstage side is facing upwards. Then I go back to a top plan view and run the convert to hanging position from the spotlight menu. I get this alert dialog which tells me that there is going to be no 2D geometry in the position. This is actually reassuring, as I don't want there to be any 2D geometry, because this hanging position is going to be rotated. So I name the position and click OK. Now what the command has done is it has purposely unrotated the symbol to show the symbol correctly. However, that's not what I want. So if I undo a couple of steps and this time put the symbol into a group and run the command again, the hanging position keeps the orientation as I need it. When the command completes, the position label is telling me that the insertion point of the hanging position is dead center of the tower geometry. Personally, I would prefer the insertion point to be a little bit more meaningful, so I'm going to need to move it. If I edit the hanging position and select the group and ungroup it, you can see that the symbol's insertion point is a long way from the hanging position insertion point. Ultimately, you want these to be the same. So I exit the hanging position profile editor and make a few more adjustments to the object's position on the Z-axis. And now I'm ready to move it into position. When I come to make the schematic view of this position, it is this top view of the unrotated hanging position that I'm going to see, and that's what I want to see. I don't really need the hanging position label, as I can use data tags later on, and all I'm going to do is rotate the hanging position into a more natural position. When adding lights to hanging positions, I tend to set the Smart Cursor to just use master snap points only, as this setting will snap to any locus geometry that has been created, and also the cursor will turn red. This makes it reassuring that the lighting device has snapped to exactly where it needs to be without having to check. To set Smart Cursor scripts up, make a selection in the Smart Cursor Settings dialog, and then go to the Tools menu. And under the Custom Tool Attribute command, select Smart Cursor Settings, and then follow the steps to naming and storing the script. So I'm going to pick this Neathammer profile spot, which is part of the Ballet company's stock, and place the lighting devices on the hanging position. Finally, I'm going to add a par 64 to the top of this position. Now I need to stand the tower up. So I go to a front view, and with the tower selected, run the Rotate tool. I'm looking for a snap point, so what I need to do is activate insertion points. I can do this with the Rotate tool still activated. The hanging position rotates and the lights follow. The next step is to reorientate the lights. So select the lights, and because the lights are selected, the tool will use the lighting device mode and will change the X and Y rotation of the devices all in one action. Currently the lights are in their home focus position, but it is quick to change the focus angle with the new Focus Lighting Devices command. With the lights selected, if I right-click on an empty space, I can get access to the new Focus Lighting Devices along a path tool, which in this instance I don't actually need. However, if I right-click on the selection, the context menu opens and the Focus Lighting Devices command can be selected. This dialog opens and I want to change the tilt of the selected lights. I can use this slider here to give me a preview, or as I know the angle I want, then I can just put in 90 degrees. Click OK, and the lights are focused. Two more things need to be looked at. Firstly, this par 64 needs to be duplicated and rotated so that it is overhung. It will also need focusing again. When you use the Focus Lighting Devices tool, it's important to understand that these values are relative to the focus the instrument currently holds. If you want absolute pan and tilt, then you need to use the fields in the Object Information palette or home it first by using this button at the bottom of the palette. If you worry about these things, and for some reason I do, then you will probably want to split the positioning of these instruments. One last thing you can do is to remove the hook clamps from the profiles, particularly as currently the instruments don't really fit within the frames. If you go to the Accessories tool, you will see that it has been completely reworked and it has a Remove Accessory mode. You can see that by selecting each instrument and clicking it, the hook clamp has been removed and the instrument adjusts accordingly. To look at what is going on to achieve this, I need to take a look inside the symbol. I need to locate the symbol in the Resource Manager and take a look at the 3D component. What you will see is that the clamp has the light info record attached to it and is now classed as a static accessory. It also has the parts record attached with the base field checked. What is different about the symbol, as opposed to the old style symbols, is that if you want this functionality to work, you will need to place the yoke and body geometry where you will want it to be when the hook clamp is removed, and place the hook clamp on top. It's also important to understand that the insertion point of the hook clamp symbol must be at the center of where you want it to wrap the barrel or truss cord. For this symbol, I'm going to offset it so that it sits snugly beneath the box steel of the boom tower. Now it is time to create the schematic view. So select the hanging position and go to the Spotlight Visualization menu and run the Create Schematic View command. The crucial item here is View. You must select Top. This will give you the top component of the instrument, as well as the top view of the hanging position in its unrotated, just created state, before you moved or changed anything at all. What the command now does is place a flattened view of the boom tower at the origin of the file. This is default behavior and the tool will always do this. Now all you need to do is rotate it to where you want it to be and make any adjustments to the lighting devices so that labels can easily be seen. Personally, I rotate my lights by 30 degrees off the angle. This is the way I've tended to do it for a while now and is useful in Europe where we use a lot of zoom instruments with longer lens tubes. Finally, the overhanging parcan can be offset on the schematic view. And when you do that, the schematic view creates a witness line here. It also adds a field for you to show a footprint of where the object actually is, and you can add that here. Both of these options are controllable by classes. The classes are specified in Spotlight Preferences. And if I go to the witness line class that I made, you can see that I have specified a custom line type, which is what gives me the double lines that you can see either side of the witness line on the schematic view. The Spotlight numbering tool works well with schematic views, and once you get the hang of the process, you can actually have schematic views of custom positions set up in no time. If you use boom shadows, then the schematic view object can also be quite useful. If you drag a copy of the object away from its original, along with maybe two of the lights, rotate the lights to 90 degrees and then ungroup them. All the geometry remains, but the interactivity with the original object is lost. So now select the hanging position portion and change the view to a front view. Immediately you can see that a footprint of the position has been created. Remember how the front view of the hanging position looked when it was made just a few minutes ago. You should probably ungroup it now and then select the polyline shapes of the lights as well and put them into a footprint class. This footprint class has been set up with a hatch, so they now take on the attributes of that class. Now all you need to do is align the objects together, and you can do this using the align center and align middle commands. And convert it to a symbol. Take a look at the geometry that has been made by the schematic view, as there may be some tidying up that needs to be done. But now it's a symbol, it can be done easily when it's convenient, and the changes will be pushed to all the instances you have of it in your drawing. Many lighting positions, particularly in theatres, are not necessarily the easiest to create from the stock rigging tools available to you. However, this shouldn't stop you from modelling the 3D geometry, especially if the theatre or venue is somewhere that you work often. It is perfectly possible to create lighting positions that function alongside 3D model geometry, and there are ways to utilise the geometry without having to do any redrawing at all. I want to load these perch positions with lighting equipment and have each side of the proscenium report the lights to a schematic view, whilst at the same time seeing the geometry of the 3 levels. The process that I've come up with involves creating a section viewport. So I go to a top plan view of the area I want to section. There are 2 or 3 ways to do this, but by far the most interactive is to use the clip cube. Before I do that, you can see that I've put a custom-made 3D marker symbol on the deck at a sensible reference point to the rails that I'm going to hang the lights from. This reference marker is going to come in handy later on. So I select some of the geometry I want to see in the viewport and activate the clip cube. I then go to a back view so I can see the positions from the direction I want to view them from. I tend to use OpenGL as it gives me a really good view of what I'm trying to find, and then I adjust the clip cube to just include the geometry I want to section. To create the viewport from this view, I select the face of the cube that I want to use as my cut plane and right-click on it and select Create Section Viewport. The Section Viewport dialog opens, and rather than put it on a sheet layer, which is more usual, I'm going to put the viewport on the Schematics Design layer. I'm also going to select Display Flattened, which will mean that the viewport will display only 2D geometry and always show on the screen plane only. Finally, I need to tell the viewport to render in hidden line, and any other adjustments I need to do can be made later. When I select OK, the section viewport is made and will be visible at the centre of the screen. If I now go to the Schematics layer and go to Top Plan View, you will see that a really concise render of the geometry has been made. What you can also see is the 3D marker symbol, which is going to be important in a minute. Because schematic views are generated at the internal origin of the file, I'm going to place the viewport at the origin using the 3D marker as a reference. What I'm going to do now is very quickly trace a shape of the lighting position I want to make. And I'm just going to use the line tool to draw 4 lines that will represent the geometry of the position. The vertical line is not really necessary, but I find that it is helpful later on when I start to move things around a bit more. When the lines are done, I select them and run the convert toNURBS command. This will convert the 4 lines to 3D NURBS curves, and the command will place them inside a group. If I'm going to create a hanging position that I know I'll be rotating, then all the geometry must be 3D only. All I need to do now is edit the group and place a 3D only marker at the origin. And then exit the group and convert the group to a hanging position. I name it Perch Stage Right and finish the command. Now what you can see is that the hanging position insertion point has been generated at the center of the bounding box again, and I need to do some readjustment in order to get my marker and the hanging position origins to line up. Now, the hanging position object hasn't moved, but you can see that the geometry inside it has. So you need to move the origin of the hanging position to the origin of the file again. This is easy, as you can use the Object Information palette for that. Now my markers are all lining up. If you have several of these positions to make, rather than moving everything to the origin of the file, you can always set a temporary origin by double-clicking here and following the instructions in the dialog. However, schematic views will always be generated at the internal origin of the file. Now that is all done, I need to add my lights. You can see that when I hover the lighting device over the NURBS geometry, the tool recognises the geometry as a hanging position. There is even a hanging point smart cursor cue to reassure me. Very quickly now, I can use the Move by Points tool to fill the position, and within a very short time the lights are placed on the position. Remember that I'm still in top plan and the lights are lying on the ground. However, this is the view that I want the schematic view to recreate. Nonetheless, I do need to stand this position up if I'm going to use it in a 3D view. So I select my NURBS hanging position and go to a side view and stand the position up in the same way as I did the boom towers. I also need to rotate the instruments as well. Remember that the viewport is screen plane geometry, so it is still showing top plan. When I change my design layer view to top plan, you can see that the lights are all stacked above each other, as you would expect. I'm going to select the lighting position and move it out of the way. And then I'm going to actually run the schematic view command, and you will see that schematic lights are put back at the internal origin. I've encountered lots of confusion about the rotation of hanging positions and lights when created in schematic views. It is worth mentioning that all objects, when they are created in schematic view, will be created in their unrotated state, regardless of the orientation of the original object. I think that once this is clear, it makes sense, and it is incredibly easy to select and rotate the lighting devices to get them looking right. Once you've done that, then you can manipulate the viewport and the schematic view in any way you choose. You will need to update the geometry of both the schematic view as well as the section viewport after it's been rotated. But as long as you haven't set the viewport to render at a very high 3D resolution, then this shouldn't take more than a few seconds. I find medium is quite enough for this. Now all I need to do is reorientate the lighting position to be the correct way round for the 3D model, move it to the correct design layer, and place it on the reference marker symbol I made at the beginning of this process. What you can see here is that these perch rails aren't exactly straight, and for the purposes of the 3D model, you will need to move the lights forward onto the rails. This is easily done from a top plan view, and the change you make here will make no difference to the schematic view at all. With all the lights selected and inside the clip cube, I can also easily assign a basic focus using the Focus Lighting Devices command. Here are the lighting devices hanging on the perches now. With a multi-pane window active as well, you can also see the schematic view. For me, since I've been able to model lighting positions in 3D, common rigging and focusing issues often jump out at me, and I think it's important to tackle them now rather than on site. A simple instance is the placing of this profile. It strikes me that it would be more useful placed here so that it gets a better view of the stage. Because all my position geometry has toNURBS curves embedded within it, it means that moving equipment accurately is quite simple. This is primarily because the toNURBS geometry gives me a much clearer edge for my cursor to snap to. If I set my cursor to insertion point for the lighting device and point on edge for the toNURBS curve, and using the Move by Points tool, I can pick up the lighting device by the insertion point and snap to the toNURBS curve within the other pipe. I need to adjust the rotation of the hook clamp, so I rotate the lighting device on the Z-axis by -90 degrees, and change the focus back by 90 degrees as well. And now I have an instrument in a better position. Hopefully you will have also noticed that the schematic view has also updated itself to reflect the change. One of the challenges of working in some opera houses, particularly with dance, is the depth of the proscenium. This means that this whole area is not easily reachable with sidelight. As you can see, most of the stage is quite lavishly set up for sidelight, but the area around the proscenium and apron is largely untouched. There is a possibility for a position here which will give me what I want in terms of lighting angles. The built-in rigging tools are perfect for creating schematic views, and how you go about doing that is completely up to you. However, I've come up with a workflow using hanging positions, as well as the native rigging objects, and both methods have their pros and cons. Here are a number of sidelight positions, including 3 seemingly identical booms. Each one of these is able to report to a schematic view. This goalpost was made using the standard 3D modelling tools and is inside a hanging position. The ladder is made from custom-made ladder H sections, which have been made into truss objects. This is also inside a hanging position. Lastly, these 3 booms. Each one is slightly different. This one is made from a lighting pipe, this one from a truss object, and this one is a truss object in a hanging position. All 3 of these will report to schematic views, including all the rigging like boom arms, base plates and hanging points. Here you can see a basic rigging pipe inserted at an angle of 90 degrees. So I can do this quite quickly using the lighting pipe tool, and as long as I make sure that the correct settings are set up in the mode bar, I can create a boom with just one click. What is crucial to making this work as a theatrical boom is the addition of the rigging hardware. On this boom there are 11 side arms, as well as a base plate and a hanging point. I'm just going to create a schematic view of this boom now and put it on my schematics layer. I'll also rotate the view so I can see all of it in this multi-view pane. Now the reason why these rigging items appear in the other schematic views is because they are added as point loads. These are made using the rigging load tool. So click on the rigging load tool in the rigging palette and select point load mode. You'll need to fill in the basic details in the mode bar, or if you have some saved options, then you can recall them from here. Once you have all the data in place, you can click OK, and this plumb bob will appear on the boom. Also, crucially, you will see that the rigging object appears in the schematic view. In the Object Information palette, you just need to turn off Show Name and turn on Show Symbol, and then go ahead and select the symbol you need. In this case, it is a boom arm symbol with a very specific 2D top component. It is this top component of the symbol that will appear on the schematic view. The moment the symbol is added, the schematic view will instantly change. To eradicate all the text, you can assign the class of the labels and then turn it off. To almost everybody, that process would seem rather long-winded, and if you had to do that every time you wanted to add a rigging object, then it would be a problem. However, you can save the whole object as a plug-in symbol, and then every time you want to recall the object, all you need to do is go to your library and insert it in the usual way. There is a snag with schematic views in that all objects are created in their unrotated state. So even with this method, there is still a bit of housekeeping to do. The problem with using the lighting pipe tool on its own is that the lighting pipe does not associate the lighting devices when it comes to any load calculations. This is because the lights are offset by more than the width of the pipe. This may be of little importance to you, and in which case this lighting pipe method is definitely the way to go. However, if you do want to use some of the functionality of the Braceworks tools that are available to you, then you will need to make a boom from a truss object. The reason why a truss object is preferable is because a truss object has an invisible boundary that you can specify when you convert the symbol to a truss. If I take this 7-meter length of lighting pipe that I used earlier and lay it flat on the ground again, I can use it as the basis of a truss symbol. If I convert the lighting pipe to a symbol using the Create Symbol command and make sure that the Convert to Plugin function is deselected, and once the lighting pipe is within a symbol, I can use the Convert to Truss command from the Braceworks menu to add the truss data to it. You do need to specify a weight, otherwise the load function will return an error message. If, like me, you have no idea what a lighting pipe weighs, then the lighting pipe tool will tell you, and I'll take Vectorworks' word for that. Crucially, you need to make sure that there is space around the boom pipe so that you can rig lights to the left and the right as well as forward. This space is indicated by the truss object with these markers on each end. Now, if I take a look at the loads report of this version of the position, you can see that the truss device reports the complete loading as you'd expect. Finally, my favourite option is to incorporate a truss symbol into a hanging position. Rotate it up and load it with lights and rigging point load objects in the usual way. I've made my own 3D boom truss symbols with master snap points at various useful sidearm spacings, as well as a NURBS curve down the centre, which helps me with locating snap points for lighting devices. Just as a demo, I'm going to create a schematic view of the lighting position without anything attached. The dead quick way to instantly attach all the point load hardware to the boom is to have your favourite plug-in objects already laid out in a blue symbol. The moment the grouped object is attached to a lighting pipe, truss or hanging position, the point load objects attach themselves and the schematic view is updated without any extra work. I find that what is useful about this method is that as the design progresses, I can add, remove and generally rejig boom arms, and each time I do this, the change will be reported back to the schematic view. The Move by Points tool has been updated with a preview function, which is really helpful for building booms. For the most part, it is easier to place a lighting device on the floor and then lift it into place. With the new Move mode, you can do this, and a preview will show you what the moved lighting device will look like when you've finished. To change the mode, it's also going to be easier when I get the hang of the new Smart Options display, and actually spacing a load of lights out over the length of the boom is going to be relatively painless. The advantage of using hanging positions for me is the fact that the lights will report the position name and the hanging position will report the load. It's also worth pointing out that when you do a Braceworks load overview, it will add a cable allowance. This is a value that you can set up in Braceworks preferences. Hanging positions will also report the total hung weight to a data tag, along with any position information that could be useful. This could be the distance from the centre line or a measurement from the setting or plaster line. I hope these methods of using the Schematic Views command have helped clarify some of the issues with the function, as well as offer up a few ideas as to how you can leverage 3D objects to generate meaningful and worthwhile schematics of lighting and rigging positions, which are not necessarily immediately obvious when approaching this topic for the first time. If you'd like to see some images from the actual finished production, then please take a look at my website. If you want to know more about working with Vectorworks in the entertainment and events industry and would like to book a training session with me, then please go to this page where you will find information on how to contact me.